Let's talk about Flink. It is yet another data streaming framework, and definitely wins the name for cutest name. If you're curious, Flink is the German word for quick and nimble. That's where it got its name from. And it's fitting. It is a up-and-coming package for data streaming, and it is definitely worth your consideration at this point. It's finally mature to the point where people are using it at real companies at large scale for real business problems, so it deserves a look. Mainly, Flink has been giving the other engines, Storm and Spark Streaming, a run for their money, and this is a case where competition is good, and they've been kind of pushing the other systems in the right direction. So at the end of the day, the differences between these packages are going to converge, I think, and we'll talk about that more in a bit. It's most similar to Storm. The main thing about Flink is that it is doing its streaming on an event-by-event basis, so it doesn't have micro batches like the current version of Spark Streaming does. And it can run on a standalone cluster on its own, like Spark can, or it can run on top of Yarn or Mesos, like Spark can. One thing that sets Flink apart, though, is just how highly scalable it is. It has a pretty clever distribution strategy where you can actually scale it up to thousands of nodes if you need to run truly massive deployments. And companies like Capital One and Alibaba are using variants of Flink at that sort of a scale. It's also very strong on its fault tolerance. So it uses something called state snapshots to actually make sure that you can survive a failure while still guaranteeing exactly once processing. And if you're dealing with like financial transactions or something like that, that's a big deal, right? You don't want to be reprocessing a stock trade twice just because some server went down. So Flink is thinking about those sorts of problems. How do you compare Flink to Spark Streaming and Storm? Well, there are some differences, but again, these are all changing over time. All three of these systems are evolving quickly. Right now, Flink is an order of magnitude faster than Storm in terms of throughput. So you are going to get much more performance out of Flink than Storm, which means less hardware requirement to do the same job. So that can actually save you money as well as time. Like I said, Flink offers real streaming on an event-by-event basis, kind of like Storm does if you're using the core Storm API. But keep in mind, too, I didn't mention this before, but if you're actually using that higher-level Trident API with Storm, you're actually using microbatches, just like you would be in Spark Streaming with dstreams. But, as things converge, and if you do use the core Storm API, that's also doing streaming on an event-by-event basis, and Spark Streaming is also moving in that direction with the new structured streaming API that they're currently developing. Flink does offer a higher-level API that's like Trident or Spark, but it still does real-time streaming while doing so. So programming in Flink is a lot like programming in Spark Streaming, it turns out, but instead of operating on dstreams in a microbatch level, it's processing that stream on an event-by-event basis. Flink also has good Scala support, which makes it look even more like Spark Streaming. So if you already know how to code in Spark, coding in Flink is going to be quite simple. And one thing that I'm not sure how to feel about, Flink has its own ecosystem, like Spark does. So it has machine learning libraries bolted on top of it and SQL query libraries bolted on top of it. I'm not sure how comfortable I am with them going off in their own direction, but they kind of have to. But it does bring into question the fact that Spark has a big head start on Flink in this stuff, right? So MLlib is going to be a little bit ahead of Flink's machine learning capabilities, I think, for the foreseeable future. Another important thing about Flink is that it can process data based on event times and not when the data received. And again, if you're dealing with, really important data like financial transactions, that is important. Sometimes you can have weird failure modes downstream from you where some bit of data or some stock trade might get delayed for hours or days before it actually hits your system. And you want to make sure that that gets applied in the correct order relative to other events, even if they arrived out of order to your cluster. And it has a very good windowing system that offers a lot of flexibility in how you can window that data and analyze data over time as the data flows in. But Flink is the youngest of these technologies. Like I said, it's matured quite a bit, and it is at a point where you should consider it as a viable option to Spark Streaming and Storm, and it's moving quickly. But it is still the youngest, and it's still sort of finding its footing, if you will. However, like I said, all three of those solutions do seem to be converging in terms of feature sets. Structured streaming and Spark Streaming at least paves the way for real event-based streaming and Spark Streaming. So at the end of the day, it's going to become more of a question of what best fits into your existing environment. What sort of connectors exist for your streaming solution, and how does that interact with your existing streaming data sources and where you want to store this data ultimately. So a lot of times it just comes down to what options are available to me for connecting the dots, given the dots that I have, right? Little quick view of the Flink architecture. So Flink itself is a runtime engine like Spark, and it can run on a standalone cluster, that just runs its own thing, like Spark can. It can run on top of Yarn on Hadoop, like Spark can. And you can also run Yarn and Hadoop on Amazon Web Services or on a Google Cloud. So that's just saying, yeah, you can run this in the cloud, whatever. And you can also run a local version of it if you just want to mess around with it. And that's what we're going to do at the end of this lecture. Now, on top of Flink, this is something else that's a little bit different about Flink. Not only can it process streaming data, but it can also process batch data as well. So it has two different APIs. The Data Stream API, on which you can do event processing using something called CEP, and also table-based processing where you can issue SQL-like relational queries on the data as well as it comes in. And then over here, we also have a data set API. So instead of streaming data, this is dealing with batch data. So this is unbounded data, this is bounded data. And Flink can handle both. And when you're dealing with bounded data, then you start to get into this parallel universe with Spark here. Instead of Spark's MLlib, we have Flink ML. Instead of Spark's GraphX, we have Geli for doing graph processing. And they also have a table API on top of that for doing SQL queries, just like Spark SQL. So this is basically an alternative universe, if we're looking at the right side of this picture, to Spark, where if you're dealing with bounded batch data, instead of MLlib with Spark, you have Flink ML. Instead of GraphX with Spark, you have Geli. And instead of Spark SQL, you have table. Okay, so Flink is kind of meant to be a replacement for Spark, it seems. And again, Spark has a pretty big head start, so that's a very ambitious goal, isn't it? But they're pulling it off. Currently, Flink can connect to a bunch of other systems, including HDFS, Cassandra, Kafka, and others that we haven't talked about yet, but will shortly, like Elasticsearch, NiFi, Redis, and RabbitMQ are also things that you can connect to currently with Flink. So let's mess around with it and actually run a little sample in Flink and see that it actually runs.